Let's look at a few review examples. These examples are taken from past midterm ones. One of my favorite types of questions is, what would Python print? Where you tell me what output you would see on the interactive interpreter when entering some Python code. So one of the most important things to remember is that the print function always returns none. It also displays its arguments separated by spaces when it's called. So often I'll put something like this, a small definition such as the square function, maybe import add and mul from operator. And then I'll start asking questions like, given an expression, what does it evaluate to? Or what interactive output would you see if you entered that expression in the interactive interpreter? So if you enter 5, it evaluates to 5. The interactive output is also 5. If the expression is print 5, it evaluates to none, but the interactive output does display the number 5. Now what about the value none? Well, that value is computed for print 5, but remember the interactive output does not include none if it's just the value of an expression. To ever see none here, you have to explicitly print it out. Now if you see a nested expression print 5, call expressions are evaluated by evaluating the operator, evaluating the operand. In this case, evaluating the operand prints the number 5 and evaluates to none. And then we apply the print function to this value, none, which actually prints that out in the interactive output. Now the whole thing also evaluates to none, but by printing 5 here, I get a 5, and by printing none, I get a none. So the full interactive output looks like 5 none, and the whole expression evaluates to none. Okay, then oftentimes I'll define some other simple function and ask you what it does by giving you expressions that include calls to that function. So let's look at this one. Def delay arg, print delayed, def g, return arg, return g. This is a very common pattern where you have a def statement within a def statement. I define a function g, and then I return it. What happens is, when I call delay, a new function is created, and that function g has as its parent frame the delay frame that was the first frame of the current environment when g was created, or when it was defined. So that means whenever I call g, then the body of g gets executed, and it can refer to names that are in its enclosing scope. That means names that are bound in the delay frame that was the first frame of the current environment when g was defined. So this arg refers to whatever arg was within delay when g was defined. So if I call delay on delay, and then call that, and then call that on 6, and then call that, what's going on here? Well, remember, this is one big call expression. So all the parts need to be evaluated before we can evaluate the whole thing. We talked about this, that names in nested def statements can refer to their enclosing scope, so that arg will mean something. It will mean whatever it was bound to when we called delay. And so delay is a function that takes any argument and returns a function that returns that argument. Okay, so we have some idea of what delay does. Let's just go through and figure out exactly what it means to call this call expression. So this call expression has a complex operator, which is this whole thing up to but not including the final set of parentheses. So we have to evaluate everything that's underlined here first, and then we'll apply that function to no arguments at the very end. Now what's that? Well, that's actually a call expression with a compound operator. So we now have everything up to but not including this parenthesis as something we need to evaluate, and then we'll apply that to the number 6. Okay, now what's that? Well, that's a call expression as well, and here's the compound operator, delay, delay, which will apply to no arguments. Okay, so what's delay, delay? Well, that's a call expression where I'm calling delay on itself. So what happens when I call delay on itself? Well, I get back a function of no arguments that will return whatever delay was called on, and delay was called on delay. So it will return the delay function. So we get a function that returns the delay function. But by the way, when I call delay here, it prints out delayed. So that's why we have one printed delayed. Then I'm going to call g, which is going to return to me the delay function. Then I'm going to call that function on the number 6. Calling delay on the number 6 prints delayed again and returns a function that will return 6 when I call it. Here's where I call it. So the whole thing evaluates to 6. And since that's not none, it gets printed out in the interactive output. So the value of the whole expression is 6, and what we see is delayed 6. What about print delay? Print 4. Well, we have to go through a similar process. This is a call to print with an argument that's the value of delay print, call that, and then call that on 4. So before we can figure out what we're printing, we have to figure out what this call expression evaluates to. So we're going to call delay on print, and that will print out delayed, and will give me a function that returns the print function. I call that. That's fine. So now I get back the print function. I call print on 4, and I see the number 4. And then this whole thing evaluates to exactly what print 4 would evaluate to, which is none. And that's what I print out. And the value of the whole expression is none. Let's do another one. The more practice, the better. So same format, same from operator, import, add, and mul, and define square. But here's a new function. Define pirate of arg, which prints matey, and then defines plunder arg and returns arg. And then that returns plunder. We have the same basic structure here, but this is a different function with different behavior. Not because the names are different, but because of what the inner def statement says. So the inner def statement says, whenever I call plunder, I will return its argument. Now this is not delayed in any way. This just says, I call plunder on something, I get back that thing right away. Plunder 2 is 2. And in fact, because plunder uses the name arg, we're never going to be able to refer to this arg in an enclosing scope, because the process for looking up a name always looks in the first frame of the current environment. So if we look up the name arg, we'll find it immediately, without ever looking in the parent frame. Okay, so what happens if we add pirate 3 square 4 1? Well, we're going to add whatever this evaluates to the number 1. And let's see. So we have pirate 3 square 4. So we're going to apply something to the number 4. In order to figure out what that is, we apply something to square. And what we apply to square is what we get back from calling pirate on 3. So our first task is to figure out what pirate 3 returns. Now, as I said, a name evaluates to the value bound to the name in the earliest frame of the current environment in which that name is found. And in particular, the name arg will always evaluate to the value bound to it in the plunder frame. So whenever plunder is called, we get back whatever it's called on. We'll never get to this arg up here. So what the pirate function really does is it just always returns the identity function, or the function that returns whatever argument is passed into it. So if I call pirate 3, I get back a function that will just evaluate to whatever I pass in. So if I pass in square, then this whole thing evaluates to the square function. And what happens when I square 4? I get 16. I add that to 1, and I get 17. So that's the identity function. This whole thing evaluates to square, and square 4 is 16. Now I do print out matey whenever I call pirate, so that's why we have matey here, and then 17. But the whole thing evaluates to 17. Okay, what about pirate 5 7? Well, let's take a look. First of all, we're going to apply something to 7, whatever it is, we first have to get it by applying something else to 5. And what is this thing we're going to apply? Well, first we're going to apply pirate, but what are we applying it to? Well, whatever we get by calling pirate on pirate. So this is the innermost thing that I'm going to evaluate first. Calling pirate on pirate gives me the identity function and prints out matey, of course, because every time I call pirate, I get matey printed out in the interactive output. So this gives me an identity function. I call pirate again, and that gives me another identity function and another matey. I then call that on 5. And that means I get 5 back. So far I have matey, matey, and then the whole operator expression here evaluated to the number 5. I tried to call 5 on 7. Now 5 isn't the kind of thing that you can call. You can only call functions. You can't call integers. And that's why we get an error. So this whole thing doesn't have a value because that whole thing evaluated to 5. Okay, one last example. One of my favorites that I ever came up with. The horse mask. So it says I'm going to define horse mask as a function that sets horse equal to mask, then defines mask of horse, which returns horse, and finally it returns horse, called on mask. What is mask anyway? Well, mask is a function that takes in an argument horse and calls horse on 2. And then we evaluate horse on mask. So the whole point here is that we're going to have the words horse and mask mean different things in different environments. We have to remember where we are, where we return to every time we return a value, and make sure that we're calling the right function in each step. Now, provided we have horse bound to a function called horse, which takes mask as an argument, and we also have mask bound to a lambda function that was created right here, which takes an argument horse. Both of these have as their parent the global frame. Now we call horse on mask, which means we're calling this function with this as an argument. So calling horse means that we introduce a new frame where we copy over the name of the function. We also give the new frame a label, and we bind the formal parameters of that function to the arguments that were passed in. So we're giving the name mask, which came from here, to the argument that was passed in. And we passed in whatever mask was in the global frame. Oh, it was this lambda function. So that's bound to mask here. So now we have mask meaning this lambda function in the first frame of the current environment. Now we execute the body of the function, which says figure out what mask means and bind the name horse to it. Now an assignment statement always changes something in the current frame, which is this right now. So we bind horse to whatever mask is currently equal to. Next, we define the mask function. And the mask and a def statement, remember, has 2 different steps. It creates a new function whose parent is the current frame, and then as a second step, it rebinds the name mask to that function. And that binding always happens in the current frame as well. So we create a new function called mask, argument is horse, parent is f1, because we're currently in f1, and we bind the name mask in the current frame to that function. So mask is now that function called mask, the one we defined in here, and we can't have the same name mean 2 different things in the same frame. So we have to get rid of the old binding. Now it's gone. So far we've done everything except for the return statement, which says return horse of mask. Now in order to do that, we have to figure out what horse of mask evaluates to. So we have to figure out what happens when we call the horse function on the mask argument. Now which horse function and which mask argument? We have to remember we're in this frame, the horse frame. We're in the middle of evaluating the horse function, and so we're in a horse frame, and so we figure out that currently horse means this lambda function, and mask means this mask function. So we call this lambda function with this as an argument Calling a lambda function means that we introduce a new frame. That frame has name lambda, and its parent is global because the lambda function's parent is global. We bind the formal parameter horse to the argument that we passed in. So whenever we use horse within the body of this lambda function, we're going to be talking about this. And this is the lambda function that we passed in. So what happens when we execute its body? Well, we just return the value of horse with argument 2. Which horse? Well, this is the current frame. It's this horse, which is this function. So we call this function on the argument 2, which means creating a new frame. The mask frame has parent f1 because whenever we call the mask function, this is the parent. And its argument horse is bound to 2, just like I said. And what does the mask function do? Well, the mask function just returns horse. Horse is 2, so we return 2. Now, where do we return it to? Well, the last thing that we called from was this lambda function, which was trying to figure out what horse 2 was and return that value. We just figured out that horse 2, in that context, evaluated to the number 2. And so now we need to return that. And where do we return this number 2 to? Well, we were in the middle of evaluating the body of horse mask, and we were trying to return whatever it was that we got when we called horse on mask, which we now know is the number 2. And so we can return that, and we're finished. We've figured out that calling horse mask in this way doesn't cause any errors. It generates this environment, and it evaluates to the number 2.